Hi guys, in this video we will be looking at geometric series grade 12. The first equation Sn a to the power of r n minus 1 divided by r minus 1. We use this when r is greater than 1. Similarly, we use this when r is less than 1. Right, so in this video we'll specifically focus on the proof of this equation or formula, right, of this formula. Well, if you are new to this channel, what are you waiting for? Kindly subscribe. You only subscribe once. So let's start. We will look at the proof. So I'll write proof here. I'll just write proof here. So it will be proof. Then how do we prove this? Many can ask, how do we prove it? Well, you need to formulate, you'll just say Sn, we know it's a sum. Then we'll have T1 plus T2 plus ellipsis plus Tn minus 1 plus Tn. Right, so we'll need to formulate using this these notations. We need to formulate an equation from this. So we are going to say Sn T1, guys. T1 it's the same as A, which is the first term. For T2, remember, where do we get this? Remember, if you're using a geometric, the general term of a geometric. So for term 2, if I put 2 here, it will be 2 minus 1, meaning that I'll be left with AR. I'll be left with AR plus, okay, here we'll have ARN minus 2 plus ARN minus 1. So we will name this equation 1. We will name this equation 1, guys. I hope it does make sense, right? I hope it does make sense. So that's the first thing you should do. You will write sum, then T1 plus T2 plus ellipsis plus Tn minus 1 plus Tn. Remember, this represents the general formula of a geometric series. So we have already formulated equation 1. So in order to obtain equation 2, guys, we will multiply by the constant ratio. I hope you are writing it down. In order to obtain equation 2, multiply the equation 1 by r. So in other words, we will multiply equation 1 by r. So everything will be multiplied by r. So if I multiply Sn here, it will I'm gonna be left with Rsn. So if I multiply A, I'm going to have AR. If I multiply this, I'm going to have AR squared. Remember, when the bases are the same, you add the exponents. That's why you have r squared there. Plus ellipsis. So if I multiply by r here, I'm going to be left with ARN minus 1. Why, guys, I'm left with ARN minus 1? Remember, you have, let's say you have ARN minus 2. You multiply it by r. So from here, you are going to have ARN minus 2. The bases are the same. Remember the invisible 1 here, plus 1. So what is negative 2 plus 1? That will be negative 1. So that's why we have AR to the power of n minus 1. That's how we are going to have. So similarly, even here we are going to have a ARN, because when you multiply, if you multiply this, let's say it was 1 here, you know that negative 1 plus 1, that will be 0. Then you're left with ARN. So we have formulated equation 2 by multiplying by the constant ratio of r. That's what I was emphasizing. Sorry for the background noise. At times we do face such, right? So I hope, guys, I'm making sense. I hope I'm making sense. I did show you how we came up with equation 1. Now, I did also show you how we came up with equation 2. We are going to multiply equation 1 by r, which is the constant ratio, to formulate equation 2. So what's the third step then? The third step will be to subtract equation 2 to equation 1. Is to subtract equation 2 to equation 1. Meaning that I'm going to say RSN minus SN, right? So this is what I'm going to say, RSN minus SN, right? Similarly, when we subtract this, we'll also subtract this, as well as this, as well as this. So when you subtract this, this is what you're going to be left with. You're going to be left with negative A plus A r to the power of n, right? I hope you will do that. So right now you can prove this by subtracting equation 2 to equation 1. You will see that you're left with negative A plus A to the power of Rn, right? So that's how it should be. I hope, guys, I'm making sense. What I'm saying, it does make sense to you. Remember, equation 2 minus equation 1. Then we are left with RSN minus SN, which is equals to negative A plus ARN. So from here, you can take out the common factor of A and SN, because these are the common factor. At the left hand side we have SN, at the right hand side we have A. So if we take out at the left hand side, if we take out SN, we'll be left with R here. So for us to get to negative SN, we need minus 1, because SN multiplied by negative 1 will give you SN, will give you negative SN. So from here we can take out A as the subject, as a common factor, so we'll be left with r to the power of n, because A times r to the power of n, it's ARN. So for us to get to negative A, we need negative 1. So to make our life easy, to make Sn the subject of the formula, you will have to divide everything now by Sn. Divide everything now by Sn. Am I doing it right? No. Not Sn. We are dividing by r minus 1, because we need to make Sn the subject. So we're dividing by r minus 1. So here, these are common. We cancel. Then Sn is now a subject. We are left with A to the power of Rn minus 1 divided by r minus 1. Divided by r minus 1. So we have proven the first formula. You use this formula when r is greater than 1. What about the other one? To find the other one, this one, remember, we will apply the same technique, but in this case you will subtract equation 1 minus equation 2. So when you subtract equation 1 minus equation 2 using this calculations that we have done there, you will be left with Sn minus RSN, right? So by subtracting this, we'll be left here by A minus, what do we do there? Minus ARN, right? So it's a vice versa, but you'll see how it goes about. So the highest common factor, we know that will be Sn. Then we'll be left with 1. To get to RSN, we'll need R. We'll take out the highest common factor here. So take A, then we need 1 here. To get to r to the power of n, you need r here. So you need r to the power of n, sorry for that. So we will then divide everything by 1 minus r. Divide everything by 1 minus r. So from here we can see that they cancel. So therefore Sn is equals to A, open the bracket, 1 minus r to the power of n divided by 1 minus r. So use this formula when r is less than 1. I hope I did make sense. in proving this geometric series. This is how, guys, you prove a geometric series. At times they will ask you guys to prove the geometric series proof. It's either they can ask you in June examination or in a prelim or final. So I hope, guys, I hope grade 12 this has made sense. I hope we are learning. Remember, if you're new to this channel, do the right thing, like the video, comment and subscribe. Wishing you all the best. Be well and prosper in this academic year, which is 2025. Thank you.